Welcome back, students. Today we're skipping 5.3 for now, and we're going to do Chapter 5, Lesson 4, Solving Proportions. Before I do the objective, I do want to remind you, we already talked about proportions a little bit, and they are equivalent ratios. So two ratios that are equal, those are proportions. Well, today you'll be able to solve proportions using different methods. Okay, so a good way to learn about solving proportions is to give a real life example. So here we have Erin's career on the basketball team. In that career, she made 7 out of 10 free throws. Okay, so we have a ratio right here, 7 out of 10. And last season, she attempted 60 free throws. So assuming that she keeps on the same pace, how many did she make? The first approach I want to go over and show you is called the unit rate approach. And what we're going to do there is solve it by finding the constant factor across or between the two measured spaces. So let me set it up for you. So we're going to look at the two things being compared, and we're comparing how many she made to how many she attempted. So let's look in the problem. It says right here she made 7, so I'm going to write 7. She made 7. And then it says how many did she attempt when she made 7? Well, she made 10. So that's on the same line as the 7. Well, then next it says how many did she make out of 60? Well, so we know the 60. So she attempted 60. They want to know how many she made. So if they want to know it, and we don't know it, we're going to use a variable, x. So this is how we're going to set it up. Once we set it up, doing the unit rate approach, we have to actually find the unit rate. So we need to find the unit rate for how many were made out of how many were attempted. So I'm going to divide them, and if I divide 7 divided by 10, I get 0.7 made per one attempt. So now I have a unit rate. So I'm going to take this 0.7 and I'm going to multiply it to 10. So 0.7 times 10 gives me 7. So it does work. So because once I know what he makes per attempt, I can just multiply my attempts by that. So I'm going to do that here. I'm going to take the 60 and multiply it by 0.7. And when I do 60 multiplied by 0.7, the decimal in this 0 will cancel. I end up with 42. So the answer I get is 42. So if she follows this same pattern, she should make 42 out of 60. Okay, so same problem, different way of solving it. This is called the scale factor approach. And it's solved by finding the multiplicative relationship among the elements within the measured space. Okay, that probably made no sense. I'm going to just say it in plain words. Here's what you do with the scale factor. You say, what are you multiplying the 10 by to make the 60? So what do we multiply 10 by to make 60? We multiply it by 6. So whatever I do on the right, I'll do on the left. So I am going to multiply the 7 by 6. So 6 times 7 is 42. And so I get the same answer, but I got it a different way. All right, now I want to talk about the table strategy. Now that strategy is kind of a mix of the unit rate and the factor of change strategy. What we do in this strategy is we make a table and we just continue it until we get to our desired amount. In this case, I want to get to 60. So on this side, if I count by 7s, my next number is 14. And then my next number is 21. And on this side, my next number would be 20, 10, 20, 30, 40, and then 50. And here I have 21, 28. 35 is next, and then I get to 42. So at 60 attempts, the person would make 42. So it is kind of a mixture because in a way, here you're counting by sevens and here you're counting by tens. And the reason I say it's kind of a way is because our first entry is 7, our second, third, fourth, fifth, sixth. So our sixth entry is basically 7 times 6. But what I like about this approach is it's visual, and if the numbers are not too high, you can always work your way up to your desired answer. Now the graphing strategy has a benefit because after you graph, it will allow you to write the equation. You'll be able to look at the line and determine what the slope is and the y-intercept, which we learned in the other chapter, and you'll be able to write an equation that you can use to find out any value. So in the graphing approach, I mean, it makes sense. You graph, you take your points, like from this table, and you put them into a graph. So at 10 attempts, 7 shots were made. And at 20, 14, and so on. And from this, I can graph, make my graph, and I can do my equation. And my equation would be y equals, and my slope is up 7 over 10, and my y-intercept would be 0. So this would be my equation for this line. I would like to point out that another way I could write this is y equals, instead of 7/10, I could say 0.7x. And if you remember our first strategy, I was using 0.7 in it. So a lot of these strategies kind of share something in common. Okay, the fraction strategy is a little bit like our second strategy in that you set up your fractions and you say, what do I multiply 10 by to make 60? Okay, and some kids always say, well, how do I know which ones to do that with? You look at which, the denominator or the numerator, whichever one has a partner on the other side. 10 turns into 60, so that's the one I use first. So I multiply by 6. 6 times 10 is 60. So whatever you do on the bottom, do on the top. 7 times 6 is 42. So again, I end up with 42. All right, we're going to use the fraction strategy to solve a word problem. And this particular word problem has the situation of a cafeteria serves lunch to 350 students, or I'm sorry, 530 students. I misspoke. And it says that 2/5 of them, so 2 out of 5, buy dessert. Now, it's important to read the question because the question says how many of the students did not buy dessert. So what I'm going to have to do is, if 2/5 buy, how many out of 5 do not buy? And I would say 3 out of 5 do not buy. So instead of using 2/5, I'm going to start over and write 530, and I'm going to say 3/5. Now, if you have a question on, well, Mr. DeMars, why did you set it up like that? Well, I set up 3 on top of 5 because 3 represents the kids that did not buy, and 5 represents the total. And on the left side, the 530 represents the total number of kids they have. So, now I can use the fraction approach to solve this. And what I'm going to do is I'm going to look at the bottom numbers because they both have numbers there, values. I'm going to say, what do I multiply 5 by to get 530? And I would multiply by 106. If I multiply it by 106, I get 530. So now I'm going to multiply the top by 106. So 3 times 106 is 318. So my answer would be 318 did not buy. And that's students. Students. So again, very important to read all of the question and make sure that you notice things like did and did not buy. Okay, so a good advice here about setting up your proportion first, then solve. So here we have a bubble solution for making bubbles. Can be made with a ratio of 1 part detergent to 8 parts water. So here's what I want to tell you about proportions. When you set them up, it's so important to remember what the number means. I'm doing detergent over water. So when I set up my second fraction, I need to make sure I put water where water goes. And in this case, I put it on the bottom. So I'm going to finish reading here. How much detergent would you need if you had 56 ounces of water? So because I see water and I see it here, I'm going to put water on the bottom because I put water on the denominator there. Now, the empty space gets your x. Now you can solve it using any of the methods you want. Personally, I think the fraction method will work very well here. So what do I multiply 8 by to make 56? I multiply it by 7. Well, whatever I do on the bottom, I'll do on the top. So 1 times 7 is 7. So my answer is 7 parts, and we don't know what they're measuring with, 7 parts detergent. Okay, here we have 4 kind of quick examples of when you have proportions set up and all you have to do is solve them. Notice that they did set them up correctly because they have miles on top of hours, and they were consistent and did it the second time, miles on top of hours. So in this first one, I'm going to try and do the fraction method. So I say to myself, what do you multiply 2 by to make 6? And that answer is you multiply by 3. So whatever I multiply to the bottom, I will multiply to the top. So 3 times 110 is 330. Now, please don't write it here in the fraction. What I'd prefer is that you write 330 miles and then write it by itself and circle it. Our next one, in our next example, I look and I see that 3 does not go into 8 evenly. So if I do the fraction method, I'm going to be using a decimal, and I don't like that. So I want to try and find a different method. Well, I look here, 24 minutes, 3 miles. I can reduce that and use the unit rate method. So if I reduce 24 minutes and divide it by 3, I get 8 miles, or minutes, sorry, 8 minutes. And then if I divide this by 3, I get 1. 8 minutes and 1 mile. Well, now I'll bring my other side down, m over 8. Now I can do, now that I know the unit rate, I can do the fraction method. What do I multiply 1 by to make 8? And that would be 8. So whatever I do on the bottom, do on the top. So 8 multiplied to 8 is 64. So my answer here is 64, and I need to label it. So I'm going to say 64 minutes. That would be my correct answer for that missing value. Okay, so once again, I look and I see 10 and it turns into 15. Not an easy thing to multiply by. I could multiply by 1.5, but instead I'm going to look for other options. And I see I can reduce this. Now I can't make it a unit rate, but I can reduce it. If I reduce this by dividing by 2, I get 3/5. Now I can take my b over 15. Now I can check, can 5 go into 15? And the answer is yes, 3 times. So I'm going to multiply by 3. 3 times 5 is 15. Whatever I do on the bottom, do on the top. So I'm going to multiply the top by 3. 3 times 3 is 9. So here I say b equals 9 because in a way I solved an equation. All right, one more time. Again, 6 and 9. 6 does not go into 9 evenly. So I'm going to see if I can reduce, and I'm going to divide by 2. And I get 4/3 on this side. Now I bring my other fraction down, ratio, and now I find out that 3 times 3 is 9, so that works. So because I multiplied the bottom by 3, I'll multiply the top by 3. 3 times 4 is 12. So my answer is C equals 12. All right, we have another example, and this example is solving proportion problems that involve fulcrums. A fulcrum is a balance point. So think of a simple balance like a teeter-totter. You have this and a board, you balance the board on the tip of this. Well, the fulcrum point is the point where you place it on the board so the board will perfectly balance. Now, if something's heavier on one side, you might have to move the fulcrum that way or vice versa to balance it. So there's actually a formula, a proportion, that will tell a person where to place the fulcrum. So let's read our example. In our example, we have a 150 kilogram weight is positioned 3 meters from the fulcrum. So that means 3 meters this way, this 150 pounds is sitting. Okay? Then it says if a 200 kilogram weight is placed on the board, how far apart should it be? How far apart should this be from the fulcrums for it to balance? And they're in direct proportion. Scientists have discovered that this really works. So here is how you set it up. You set it up with the proportion is the mass of your first object. So the mass of my first object is 150, its weight. That goes over the length of the second object. And the length of the second object here from the fulcrum is x. I don't know it. So I'm going to put an x right here. Then you take the mass of your second object, and so that mass is 200. And you set that over how far away your first weight was away, your first object. And that, if I look, was 3. So now that I have this set up, I can solve my proportion. The way I'm going to solve it is I'm going to say to myself, what do I multiply 200 by to make 150? And you're saying, well, nothing, because it's getting smaller. Well, what I can do is, because I want to go this direction to find my missing value, I can actually divide. I can go 200 with a calculator and divide it by 150. And I get 20 over 15, which reduces to... Okay, forget what I just said. See how I scribbled it out? I meant to say, what do I multiply 200 by to make 150? But I accidentally set it up wrong. If I want to find that out, I would actually do 150 divided by 200. And then I would get 3/4, which is 0.75. Now I'm going to multiply the top by 0.75. And I'm going to multiply the bottom by 0.75 also. And 3 multiplied to 0.75 gives me 2.25. So my advice is always, after you solve a word question, always go back and read the last sentence and then answer the question. The last sentence says, how far apart from the fulcrum should it be positioned? So my answer is 2.25, and I look here, meters. So this distance is 2.25. And if I put this 200-pound weight that far away from the balance point, the board will balance. So try the practice problems. Bring any questions you have to class tomorrow. Take care.